Welcome to qnawire.
Our question says that we have two long parallel wires that are a distance apart r of 15 centimeters or 0.015 meters. Wire A carries a current of 2.0 amperes. I call that I sub A. And wire B carries a current I sub B of 4 amperes. It wants us to, part A, calculate the magnetic field due to wire A at the position B. Okay, so to do that, for part A, we simply write out the expression for the magnetic field due to a current carrying, or a wire carrying a current. So B sub A, magnetic field due to current A, is going to be mu naught, the magnetic permeability of free space, times I sub A, the current in wire A, divided by 2 times pi times the distance away from the wire that we're considering the magnetic field to be. So that's R. Plugging those values into this expression, we find that this is equal to 2.67 times 10 to the minus 6 Tesla, which we can box in as our solution for part A. Part B wants us to find the magnetic field due to wire B at wire A. So we're going to do the exact same thing that we did for part A, except for this time, we're going to replace the current with the current in wire B. So we can call this B sub B for the magnetic field from wire B. And this is going to be mu naught times I sub B divided by 2 times pi, and the distance here is the same, it's just r. So this is times 2 pi r. So plugging those values in, we find that this is equal to 5.33 times 10 to the minus 6 Tesla. So we can box that in as our solution for part B of the question. Part C of our question asks us to do a little comparison. It says, are the two magnetic fields equal and are they opposite? Well, it's pretty clear by looking at them that they are not equal, but they are in opposite directions here. So we can say that, let's indicate this is part C first. And we can say that B sub A does not equal B sub B. And we can say, let's think, what's the best way to say this? We can say while they are opposite, they are not equal. And the reason they're not equal is because they don't have the same current. Because I sub A does not equal I sub B, and that's how we calculate those two values. Oh, little mistake there. Let's go ahead and box this in as our solution for part C. And then there's one more part to this question. Part D says, determine the force per unit length on wire A due to B and on wire B due to A. Are these two forces equal and opposite? Why or why not? Okay, so let's start one more fresh page to do this part D. Okay, so the force on A, we'll call this F of A, is equal to the magnetic field from B. So the force from wire B is acting on A times the current in wire A. Plugging those values into this expression, we find that this is equal to 1.1 times 10 to the minus 6 newtons per meter, or excuse me, times 10 to the minus 5 newtons per meter, because this is force per unit length. Okay, F sub B is going to be equal to B sub A times I sub B. Okay, so plugging these values in, we find that this is also equal to 1.1 times 10 to the minus 5 Newton per meter, because again, it's force per unit length. So we can box both of those in as part of our solution to the question. And then the next part says, are they equal and are they opposite? Why or why not? We can say F of A equals F of B, right? We just found that to be true. So we can say they are equal, comma, but they are attractive forces. So they're not necessarily opposite since they're attractive forces due to the wire current. Actually, let's say due to the current in the wires flowing in the same direction. So why are they equal? Why did they end up being equal? Well, the reason they're equal is because F of A is the magnetic field of B times the current of A. The magnetic field of B uses the current of B. So essentially, F of A is proportional to I sub B times I sub A. And F of B is also going to be proportional to I sub B times I sub A. And all the other constants in the magnetic field calculation, if we go back here, all the other constants are the same in both. It's mu naught over 2 pi r. So that's why they end up being the same. But we can also box this in as the second part of our solution to part D. And that is the final solution to our question.